Hello, Chemistry 11. Today we're going to calculate the amount of excess reactant left over after a reaction is complete. The key thing to find the amount of excess reactant left over, you will need to know the amount of the excess reactant at the start, and you're going to subtract the amount of excess reactant used up in the reaction. Okay, now the amount that you are given at the start, this will be given in the question. Okay, and the amount that is used up, well, if you think about your reaction, you have two reactants, your limiting reactant and your excess reactant. The limiting reactant gets all used up. So you are going to calculate how much excess reactant gets used up by reacting with the limiting reactant. So you're actually going to use the limiting reactant to calculate how much of the excess reactant gets used up. So we'll come back to this as we get to that point in our example. Okay, so we are going to skip some parts of our question today because there's a whole lot of math that goes into figuring out who is the excess reactant, who's the limiting reactant. So we're going to do a question and we're going to assume that you have done all the math and all the figuring out to figure out who is the limiting reactant and who is the excess reactant. So here is our problem. A 2-gram sample of ammonia. And if you don't remember ammonia, it is NH3. That's worth memorizing. It reacts with 4.00 grams of oxygen. Okay, and hopefully you remember that oxygen is a little bit special because it is not just O, but O2. Okay, so they react together according to the following unbalanced reaction. So we have NH3, ammonia. Notice NH3 and NH4 are similar. Ammonium is NH4. That is the ammonium ion. And NH3 is ammonia, and it is a neutral molecule. Okay, NH3 plus O2 gives us NO plus H2O, and we will assume that you have done all the work and you have discovered that O2 is the limiting reactant and that NH3 is the excess reactant. Okay, LR for limiting reactant, excess for excess reactant. Well, to go any further with this, and you would have done this in order to figure out who the limiting and excess reactants, where anytime you do stoichiometry, you absolutely must do what to your equation? You absolutely have to balance it. And this one's a little complicated to balance, so I'm just going to throw it in. Again, check out the end of the video if you want to see the step-by-step process for this. Okay, so now we have a balanced reaction. We cannot do stoichiometry without having those coefficients. Okay, so we want to find, going back here, the amount of excess reactant left over, and that is equal to the amount of excess reactant at the start. Okay, and the excess reactant, remember, was the ammonia. Ooh, that didn't work very well. Oh, it did. Okay. So how much ammonia did we have at the start? We had 2 grams of ammonia. So let's write down our formula. Ooh, it's going all over today. There we go. So we want to find our excess reactant left over. So that's going to be our NH3. And we are starting with the excess reactant at the start, and that is 2.00 grams of NH3. That was given in the question. And then we have to figure out how much we got used up, so we need the excess reactant used up. Well, if we're working with grams for the amount of excess reactant at the start, then we have to have this is going to be our grams of NH3 used up. Who is using it up? Well, that's going to be your O2. All of your O2 is going to react, and whatever of the NH3 reacts will be however much goes with the O2. So we are going to calculate the grams of NH3 which are used up, reacting with the limiting reactant, in this case O2. So let's start with our O2, because that's what we know about already. We know we have 4 grams of O2. Four grams of O2. First thing you want to do is you want to convert grams of O2 into moles of O2, because once you know the moles of O2, you can use your mole ratio from the balanced equation to convert into NH3. So there's 1 mole of O2 for every 32.0 grams. Okay, grams of O2 cancel out. Now we're trying to get to NH3, right? So we want to cancel moles of O2 and find moles of NH3. And anytime we're converting between moles and moles, we use the mole ratio from the coefficients in the balanced equation. And so what is the coefficient of NH3? It is a 4, and the coefficient of O2 is a 5. So the coefficient of NH3 is a 2, and the coefficient of O2 is a 5. Did I get that right? I feel like I didn't. No, it's a 4. This is a 4. There we go. Okay, so now that gives us our moles of NH3 that'll be used, and our final step is going to be to convert that into grams of NH3 per mole. NH3. And of course, for that conversion, we use the molar mass. Nitrogen is 14, hydrogen are each 1, so 14 plus 3 is 17.0 grams of NH3 per 1 mole. All right. And I'm going to cheat and look at my answer key. We get 1.70 grams of NH3 is used up. All right, well, that's just great. So now, I'm just going to take that out of there so we actually can finish our equation. We're going to take this amount that's used up and plug it in to the equation here. So that's going to be minus 1.70 grams of NH3, and we end up with 0.30 grams of NH3. And because my number is like in the middle of a whole bunch of calculations, I would definitely make sure that I put a box around that to show that that is my final answer. I might even put a star beside it or something. Okay. And how many significant figures should we have in our answer? We have just done a subtraction. And if you recall, with a subtraction, you go to the first uncertain digit, which in this case is that hundredths position. Okay, so there is our uncertain digit, and that means that we are going to have 2 sig figs. Remember, the rule for addition and subtraction is different from multiplication and division. Multiplication and division, you go to the least number of sig figs, but with addition and subtraction, you go to the first uncertain digit, which in this case is the hundredths position. Okay, and that is your final answer there. All right, if you felt good about that, you don't want to see any how I balance the equation or anything, you can stop the video at this point. But if you would like to see how I determined that oxygen was the excess reactant, if you'd like to see how I balanced the equation, you can keep going. Okay, so this part is going to be about balancing the reaction. So we had NH3 plus O2 goes to H2O plus NO. Okay. So we have 3 elements to balance. We have nitrogen, we have hydrogen, and we have oxygen. And I'm going to leave oxygen till last because I see it's on its own. Let's see. So I'm actually going to start with hydrogen because I can see I have a little problem. I can see I've got a 2 here and I've got a 3 here, and so that's not particularly helpful. Oh, I should write down how many I have to start with. Right, I have 1 nitrogen, 3 hydrogen, 2 oxygen. Over here I have 1 nitrogen, 2 hydrogen, and 2 oxygen. So like I said, I'm going to start with my hydrogen because I've got this sort of little problematic 3 and 2. Whenever you have something like that, just try and find your lowest common multiple. In this case, the lowest common multiple is 6. So if I multiply this by 2, that's going to give me 6 hydrogens. If I multiply this one by 3, that's going to give us 6 hydrogens. Now, of course, we have also changed our nitrogen, so now we have 2 nitrogens. And that means, oh, and over here, I've also changed my oxygen, so I have 3 oxygens plus another 1 oxygen gives me 4 oxygens. All right, how close am I getting? I'm not bad. Okay, so let's now do our nitrogens because we're going to leave oxygen till last. So we now have three oxygens, two oxygens, three, four. Four. Sorry, I got a little, it's only like 10 to 6 in the morning, so my brain's a little foggy. Okay, here we go. We have two nitrogens, so we need to have two nitrogens. That's going to change that there. That also changes my number of oxygens. I go from having, now I have 3 plus 2 is 5 oxygens. Now, I've got this nasty little odd number oxygen, even number oxygen. Remember though, I can multiply by halves. So a half, 1/2 of an O2 is equal to 1 O. 3/2 of an O2 is equal to, oh my God, I can't write, 1 O. There we go. 3/2 of an O2 is equal to 3 O's. 5/2 of an O2 is equal to 5 oxygen. So I'm going to say here I have 5 halves oxygen. Now we don't want to have fractions there, so we're going to take the whole thing and we're going to multiply it by 2. Okay, so that's going to give us now 2 times 2 is 4 NH3 plus 2 times 5/2 is 5 O2 gives us 2 times 3 is 6 H2O plus 2 times 2 is 4 NO. And there you are. So that's how we balanced that equation. Okay, if you still want to stick around and see how we found out who was the limiting reactant and who is the excess reactant, that's what we're going to do now. Okay, who is the limiting reactant? Who is the excess reactant? And our question again, because I've forgotten what it was, even if you haven't, is we have a 2-gram sample of NH3 reacts with a 4-gram sample of O2 according to, and this time we're going to have the balanced equation. That is our 4 NH3 plus 5 O2 gives 4 NO plus 6 H2O. Okay, to find who is the limiting reactant and who is the excess reactant, we need to find moles of the product that could be produced from each reactant. It doesn't matter which product you use. You could choose, in this case, you could choose either NO or you could choose H2O. Doesn't matter which, as long as you do the same product from both reactants. I don't know, let's choose NO in this case. So we are going to find the moles of product NO, and we're going to find that from reactant number 1, NH3. We are also going to find moles of NO from H2O. No, not from H2O. That's not our other reactant. Our other reactant is the O2. Okay, so there's reactant A and reactant B. So How many moles of NO from NH3? Well, we start with 2 grams of NH3. 2 grams of NH3 times 1 mole of NH3 for every 17 grams of NH3. That'll give us our moles of NH3. Once we have converted into moles, remember, first thing you do in stoichiometry, always convert to moles. If you've got grams, find your moles. Now we have moles of NH3, we want to find moles of product, so we're going to convert into moles of NO. Okay, and we're going to cancel our moles of NH3. Where do we find that? Those numbers that go in that mole ratio, they come from the coefficients of the balanced equation. In this case, we have a 4 for our NO, and we have a 4, oh, that's a nice ratio, for our NH3. And so 2 divided by 17 times essentially 1 is 0.1176 moles of NO. That's how much could be formed from the NH3. Find the moles of your product, the NO, from the other reactant, the O2. So we're starting with 4.00 grams of O2 times 1 mole of O2 per 32.0 grams of O2. And then we're going to multiply that by, let's see, where are we at here? Now we have moles of O2. We want to cancel moles of O2 and find moles of our product, NO. Okay, so that our coefficient for the NO is a 4. Our coefficient for the O2 is a 5. We do that and we get, oh my goodness, 0.1000 moles of NO. And our second thing that we do to find a limiting reactant is we say, who made the smaller amount of product? Who limited the amount of product? Who limited the amount of product? That's going to be the one that made the smaller amount. And who made the smaller amount? That would be, whoa, thought that was a highlighter. That would be your O2. So that means our O2 is our limiting reactant. And if O2 is the limiting reactant, then it follows that NH3 must be the excess reactant. And there you go. That's it for today.